Hello students, this is Dr. Nimulamshi here. So at present we are running with the topic isomerism in coordination complexes. So till my last class we have discussed there are about isomerism, and there are two types of isomerism. One is structural isomerism and the other one is stereo or space isomerism. And among the structural isomerism is divided into four categories, that is ionization isomerism, then heightened isomerism, number 3 coordination isomerism, and number 4 linkage isomerism. And this we have discussed thoroughly, and then we have discussed about stereo or space isomerism, and then the stereo or space isomerism is divided into two types. One is called geometrical isomerism, and the other one is called optical isomerism. And then what is geometrical isomerism means the compound to similar ligands, complex compound in which two similar ligands are present at the same side of the central metal atom. That isomer is called cis isomer. And if the same ligands or similar ligands are present at two opposite sides, then these are called trans isomer. Then we have studied about geometrical isomerism in square planar complexes, and we have studied each and every type thoroughly. So now today we are going to discuss geometrical isomerism in octahedral complexes. So what we are going to discuss, that is geometrical isomerism in octahedral complex. Okay. Now in octahedral complex means the coordination number of the complex is equal to 6. Coordination number of the complex is equal to 6. So the first type we are going to discuss is MA4. Number 1 type is MA4 B2 type, means two ligands are this B. If A is one type of ligand and B is another type of ligand, then this ligand, A ligand, are four A ligand are there and two B ligands are there. Two type of B ligands are there. So let's see how they exist as an isomer. So let's take one example, CONH3, CO, then NH3, okay, then NH3, another one, then NH3, okay, and then here also NH3, so CONH34, so CONH34, that is MA4 type, it is here bन गया MA4 type, and then we have here Cl and here also Cl. So these ligands are these Cl, these are at the same side of central metal atom. So this is a cis isomer. Okay, and the trans isomer will be the trans isomer, and this is a positive complex cation, and the trans isomer is CO. Then here we give NH3. Here we will give Cl, here also NH3, here also NH3, here Cl, and here also NH3. So it is an octahedral complex. So this is an octahedral complex, and it is a trans isomer. Because these two Cl are at the opposite side of this central metal atom. So this is a trans isomer. Okay. So next type we are going to discuss is MAA2 B2 type. MAA2, number 2 is MAA2 B2 type. Okay. So the what is number 2? Number 2 we are going to discuss is MA2 B2 type. Okay. So let's see how this one goes. So MAA2 B2 type. This is number 2. So number 2 is MA2 B2 M AA2 B2 type. Okay, so this type, see, let's take one example. Here also again CO, then here Cl, here also Cl, here also here one ligand is there, and here also one ligand is there. So this ligand is En. En means ethylene diamine. This ligand is also En. So if we take any one, this one, if we take any one, this is the octahedral complex. So if we take any one of them, so if we take any one, so this one, let us take this one. So this is En, Cl, Cl. So these two Cl atoms are at the same side of the centimeter atom or ion, and it is also a complex cation. So there are two Cl atoms at the same side of the centimeter atom or ion, and two En are also at the same side of the centimeter atom or ion. Now what happens if we take this En at two different positions, or if we take this Cl at two different positions? Okay, so let's see how it happens. So this is one octahedral. This is another octahedral complex. I am going to draw here. This is another octahedral complex. Okay, so this is another octahedral complex. So these two N are now at the opposite positions. Now these two N are at the opposite position, and similarly these two Cl are also at the opposite position. So this is a trans isomer. So this is cis isomer and this is trans isomer. Okay, so this is how geometrical isomerism is being exhibited by AA2M, AA2B2 type complexes. Okay, next octahedral complexes we have where all the ligands different. We have all the ligands different. So let's see what I am saying. Let's see in details. So this MA means all the ligands, means all the 6 ligands are different. So what happens for this kind of isomerism? So number 3 type is M, A, B, C, D, E, F type, and this will show 50. This will have 15 isomers. So this is only you have to remember then that M, A, B, C, D, E, F type have 15 different isomers. No need to go for the name and structure because this is not in your higher secondary syllabus. So if you study chemistry specialization course, then only you will study this one. Just you remember the coordination complexes of the type M, A, B, C, D, E, F type. They exhibit 15 different isomers. Okay. Next isomer which we are going to discuss is next type we are going to discuss is facial and meridional isomer. Okay. So number 4 is facial, or in short we give it as fact, and meridional. Okay, meridional. In short we give it as back. So facial and meridional isomer. Okay. So facial and meridional isomer. So what is first we have to know what is facial and meridional isomer. So let us take one. Suppose this is 1 centimeter atom. This is one ligand, and this is another ligand. Okay. Now here I am going to use a different color because it will be useful for you people. So if I take the ligand as like this, or if we take the coordination complex like this, if we do octahedral complex like this, it will be more beneficial for you people. So it will be more beneficial. So for which I am going to draw this type. Okay. So this is centimeter atom or ion, and now so here we have a type of ligand, Here also we have A type of ligand. Here also we have A type of ligand. Here also we have B type of ligand, and here B type of ligand, and here B type of ligand. Now see, these three ligand, B ligand, whether you take B ligand or you take A ligand, these ligand, these ligands, these B type of ligands, they are at the, these B type of ligands, they are at the same triangular face of octahedron, at the same triangular face of octahedron. Okay, so they are at the same triangular face of octahedron, same triangular face of octahedron. Or you take this one, or you take A to A, these are the same triangular face of octahedron. So this is a facial isomer. This is a facial isomer. So if the three ligands and this is exhibited by this type, this is exhibited by the type is Ma3B3 type. So the type is Ma3B3 type. Okay. So if that means Ma3B3 type means the three ligands are same, while the other three ligands are also same. So I have taken, for example, B as one ligand and small a as another ligand. So these ligands, if they are the same face of the same triangular face of octahedron, then that is called facial isomer or fact isomer. And if the ligands are on the same equatorial plane, if the ligands are on the same equatorial plane, so what I am saying, you just try to follow. So same equatorial plane means if I take this one, suppose this is a same equatorial plane which I am going to draw. So which I am going to draw here. So just see it very carefully. Okay. So this we are having as A. Here I am giving A. Here A. Here A, and here also A. And this one also. This one is B, this one is B, and this one is also B, this one is also B. Okay, so this one is B, this one is secondary atom or ion. So now here also another B. So they are at the same phase, here in facial isomer, the three ligands are at the same phase of the same triangular face of octahedron. The three ligands are at the same triangular face of octahedron. But in this isomer, these three ligands are on the same equatorial plane of octahedron. Same equatorial plane of octahedron. So if I draw a plane like this, or you can draw a plane like this also. We can draw a plane, so they are at the same plane of or you can draw a plane like this also. So this isomer is called meridional or Mach isomer. Okay. So if three ligands, this is very important. That's why I am giving on start to this one. So far as your entrance as well as final exam is concerned, if the Ma3B3 type isomer, or if A3B3 type of coordination complexes, if the three ligands are at the same face or same triangular face of octahedron, then that isomer is called facial or fact isomer. And if three ligands are on the same equatorial plane of octahedron, then that isomer is called meridional isomer. Okay, that isomer is called meridional isomer. Okay, so let's see how it goes. So if I take this let us take an example. So the example I am going to take is, so the example I am going to take here, just I am not going to rub this one totally because it will be helpful to us. So the example I am taking, the first example which I am taking is this one, CONH3 thrice Cl3. The first example which I am going to take is CONH3 thrice Cl3. This is also Na3B3 type. So you can give it over here. This is NH3, NH3. This is NH3. Okay, and this is NH3. Okay, this is NH3, and here also 3Cl are the same triangular face of octahedron. So this is a fact isomer, and if I want to draw meridional isomer, so this, if I give it Cl, BsCl, so this is Cl, this is also Cl, and this is also Cl. Okay, and here in case of A, in place of A, I will give NH3. Here also NH3, and here in place of A also I am giving here NH3. So see the three ligands Cl, here Cl are one kind of three ligand, and NH3 is another kind of three ligand. So the three ligands are at the same triangular face of octahedron, so it is a fact isomer, and the three ligands are at the same equatorial plane of octahedron, so it is a meridional isomer. Okay, so this is how we distinguish between fact isomer and meridional isomer. Another example I am going to take is RHCl3 RH. Another example I am going to take is RHCl3 PY3 RHCl3 PY3. So RHCl3 and PY also 3. Okay, so this is also Na3B3 type. So here also I am going to give. So suppose here it is RH. So here it is RH. So this is Cl, while this is RH, and this is PY. So this is PY. This is also PY. This is also PY, and this is also PY. So the three ligands are the same face of same triangular face of octahedron. And here in this case, if I give here RH, then the three ligands are at the same equatorial plane of octahedron. The three ligands are at the same equatorial plane of octahedron. And this isomer is called meridional isomer. The isomer is called meridional isomer. Okay. So this is very important so far as your final exam or entrance exam is concerned. So this is all about facial and meridional isomer. Now some important points to be noted is or are: geometrical isomerism is not shown by the complexes. Number one, geometrical isomerism is not shown by some of the coordination complexes. So what are those? So number one, geometrical isomerism is not shown by complexes with coordination number 2 and 3. Geometrical isomerism is not shown by complexes with coordination number 2 and 3. Next, second point is coordination number complexes with coordination number 4 means having tetrahedral geometry. Coordination number 4, we can have two types of geometry: square planar geometry and tetrahedral geometry. So the coordination complexes with coordination number 4 having tetrahedral geometry, they do not possess this geometrical isomerism, because all the positions are adjacent to each other. So it is also a 1 mark question, very important question. Why geometrical isomerism is not shown by coordination complexes with coordination number 4? Because we know that with coordination number 4, all the complexes show geometrical isomerism, and we have also studied that one in our previous class. So coordination number 4 means we can have two types of geometry possible. One is square planar geometry and another one is tetrahedral geometry. So the coordination complexes with tetrahedral geometry, they do not show geometrical isomerism because all the positions are adjacent to each other. Next is square planar complexes of the type Ma3b. Square planar complexes of the type means the coordination complexes is not number 1. I am writing here. So let me write it over here so that it will be of help to you people. So now geometrical isomerism is not shown by complexes with coordination number 2 and 3. The first one is this is geometrical isomerism not shown by the complexes with coordination number 2 and 3. Okay. Number 2 is geometrical isomerism is not shown by the complexes with coordination number 4 having tetrahedral geometry because all the positions of ligands are adjacent to each other. So if I draw one coordination complex, if I suppose this is a metal atom, so if I draw one coordination complex like this, so it will, the tetrahedral complexes will not show this type of the condition number 4, but the condition number is 4, but the geometry is tetrahedral, so it is not shown by the metals with it is not shown by the metals. It is not shown by the coordination complex having tetrahedral geometry because all the positions are adjacent to each other. Because all the positions of the ligands are adjacent to each other. Next is coordination number is not shown by, this number second point I have discussed. Next is third point is coordination number 4 means having square planar geometry. These are having square planar geometry, but this having square planar geometry is coordination number 4. The coordination geometrical isomerism is not shown by the complexes of MA3B or MAB3 type. Why? Because the spatial arrangement of ligands are equivalent. So the third point is geometrical isomerism is not shown by complexes with coordination number 4 having square planar geometry of the type MA3B or MAB3 because the spatial arrangement of the ligands are equivalent. Okay. Next is coordination number octahedral complexes of formula. Number fourth point is octahedral complexes of formula of coordination number 6. Coordination number is equal to 6. Is not shown by complexes of M6 type or MA5B type due to because also here the same reason because the spatial arrangement of ligands are equivalent. Now this is all about geometrical isomerism in square planar complexes, means the coordination number is 4, and in octahedral complexes means the coordination number is 6. So but geometrical isomerism is not exhibited by or not shown by these 4 kind of coordination complexes. First one is coordination complexes with coordination number 2 and 3 do not exhibit geometrical isomerism. And the second point is coordination complexes with coordination number 4 having tetrahedral geometry do not exhibit geometrical isomerism. Why? Because all the positions of ligands are adjacent to each other. The third point is coordination complexes with coordination number 4 having square planar geometry of type MA3B or MAB3. Okay, do not show or do not exhibit geometrical isomerism. Why? Because the spatial arrangement of ligands are equivalent. Next is coordination complexes of the coordination complexes or having coordination number 6, but the type is MA6 or MA5B type. Here also they do not possess or they do not exhibit geometrical isomerism because the same reason, because the spatial arrangement of ligands are equivalent. So with this we have finished the discussion regarding geometrical isomerism of coordination complexes. Next we are going to shift ourselves to the Optical isomerism means the optical isomerism. Now, what is optical isomerism? What is optical isomerism? We have read some points about optical isomerism in your first year syllabus, and also so far I know that you have read something about optical isomerism in your organic chemistry first chapter. Okay, alkynes and halogens. Okay. Now, what is optical isomerism? Compounds, there are compounds which rotate the plane polarized light. There are compounds which rotate the plane polarized light towards right. And the same compound, same molecular formula, the compound having the same molecular formula, there some compounds are there which rotate the plane polarized light towards left. So, the compound or the isomer, so they are having same molecular formula, but they are having different property. So they are called isomers, and the phenomenon is called optical isomerism. So the compound which rotates the plane polarized light towards right is called dextrorotatory, and the compound which rotates the plane polarized light towards left is called levorotatory. Okay, so this is all about optical isomerism. Now, this optical isomerism is also exhibited by various complexes, octahedral complexes especially. Now, octahedral complexes, so if some complex rotate the plane polarized light towards right, means that isomer is called D isomer or dextrorotatory isomer, and if some compound rotates the plane polarized light towards left, then that isomer is called levorotatory isomer or L isomer. So, in details we are going to study that one. So the first complexes of the type is octahedral complexes of type Ma2B2C2 type. Ma2B2C2 type. So let's finish it as soon as possible we can. So first complexes which we are going to discuss is octahedral complexes. Definitely means the coordination number is 6. The coordination number is 6. So the first one which we are going to discuss is this one. So the first one is Ma2B2C2 type octahedral complexes, but octahedral complexes. So octahedral complexes, and the type is Ma2B2C2 type. Okay. Octahedral complexes and the type is Ma2B2C2 type. So let's take one example. Platinum Pt NH3 twice, Cl2 and Py twice. So Pt here I am giving. So here I am giving the octahedral complex. Okay. So I am drawing here. So this is one octahedral complex. So Pt should be at the middle. So Pt. So this is one octahedral complex. This is one octahedral complex, and here we have Py, here we have Py, here we have NH3, here also we have NH3, and here Cl and Cl. So this is a coordination complex, and this is a positive cationic coordination complex. Now if this rotates the plane polarized light towards right, then this one will rotate the plane polarized light, means the plane polarized light towards left. Now one thing I want to say here, that there are compounds which exhibit optical isomerism, and the compounds which exhibit optical isomerism, they are mirror images of each other. The compounds which exhibit optical isomerism, they are mirror images of each other. So if one image rotates the plane polarized light towards right, that is D isomer, and this mirror image will rotate the plane polarized light towards left, that is L isomer or levorotatory isomer. So what will be the L isomer of this compound? All this will come this one. All these two ligands will come this side, and these two ligands will come this side, but there will be no effect on these two ligands. There will be no effect on these two ligands. So let's see how it happens. So this is another complex which I am going to draw here. This is another complex. Okay. So this is platinum here. So this is Cl. This is Cl. Okay. So this is NH3, this is NH3, this is Py, this is Py, and this is again NH3. So this is the mirror image of this one. So mirror image we are going to show it like this. This is mirror. So if this is D isomer, then this one is L isomer. If this is D isomer, if it rotates the preference right towards right, is called D isomer. Then this one is L isomer. So D isomer also you can write class isomer, okay, that you have studied already in your organic chemistry. And L isomer you can write L isomer, okay. So this is one example which we have cited, okay. So next example, next is octahedral complexes of MAA2B2 type or MAA2B2 type, okay. So let me draw it here. MAA2B2 type, and the complex is here I am going to give CO, okay. Here also I am going to give definitely CO, okay. So these are mirror images definitely. So En, this is here one En is there, this is one En is there, and here also one En will be there. So this is En, okay, and it means ethylene diamine. This is another En. This means ethylene diamine. So it is a positive complex, positive coordination complex, and here we have Cl. Here we have Cl. Here also we have Cl. Now if it rotates the plane for us right towards right, means it becomes D isomer or class isomer. Then its mirror image will be the isomer which will rotate the plane for us right towards left. The mirror images will be what the mirror image will be. Can you say, can anyone distinguish between this one, or can anyone say anything about this one? So the mirror images will be same, almost the same. So the mirror images will be something like that. Mirror images. Here I am going to show the mirror images. So this Cl, there will be no effect on the position of Cl. So this is En, this is En, and this is also En. Okay. So this is the mirror image of this one. So this is another type for the octahedral complexes MAA2B2 type. Okay. So let's see another complexes. Let's see another complexes of the type MAA2BC type. MAA2BC type. MAA2BC type. Okay. The third one is MAA2BC type. Means this one is same. This one is same. So I am going to draw here. I think. So this is 2 plus, it will be 2 plus, it will be 2 plus, it will be 2 plus. So this is MAA2BC type. I am going to draw here. Just look at the coordination complex very carefully. So this is En, this is En. Okay, so this is 2 positive. Okay, and this is En, then this is also En, this is also En, and then this one is NH3 and this one is Cl. NH3 and this one is this one is Cl. Okay, so its mirror image will be something like this. The mirror image will be how the mirror image will be. This portion will come this side. This portion will come this side. So how the mirror image? Let's see how the mirror image will be. So this portion will come this side. So see how it becomes. So this one will become En, and this one will come here En. Okay, and this one will come here Cl, and this one NH3 will come here, and it is a 2 positive complex. So this is the mirror image of this one. So this is octahedral complexes of MAA2BC type. Okay. Next is octahedral complexes of MAA3 type. Octahedral complexes of MAA3 type. So it is very easy. MAA3 type is very easy because means the ligand is a bidentate one definitely, and it will be something like this. It will be something like this. So the centimeter atom is, here is CO again, here is CO again. So here also we have this one. So here also we have this one. So this is En. Okay. So it will have its mirror image something like this. It will have its mirror image something like this. This portion will come. This portion will come this side. This portion will come left side. So the mirror image will be something like this. So let's see how the mirror image is. And this is En. This is En. Okay. This is En. This is En. Okay. So let me draw it very neatly so that it will be easy for people to understand. So this is En. Okay. And the coordination complex is a 2 positive coordination complex. Okay. So the mirror, this is if this compound rotates the plane polarized light towards right, and that way that one definitely rotates the plane polarized light towards left. So this is all about optical isomerism. Now first again I am going to say that optical isomerism is shown by complex compound where the molecules are not superimposable. Molecules are not superimposable means if I take these two hands, these two hands are superimposable means, but if we take our mirror images, that will be non-superimposable means one image will not superimpose on another image, means that the mirror images are always non-superimposable. This means that optical isomerism is shown by complex compounds where the compounds are non-superimposable, when the compounds have are not superimposable on their mirror images, that is they are chiral molecules. So if one ion isomer, so such molecules can rotate the plane polarized light. The isomer which rotates the plane of polarized light towards right is called extrarotatory, and the isomer which rotates the plane of polarized light towards left is called laboratory. So extrarotatory isomer is designated as D isomer or plus isomer, and the laboratory isomer is designated as L isomer or minus isomer. So we have discussed some octahedral complexes of various types of 4 different types. So you practice from any other source like NCERT or many other books are there available in the market. So you practice and you collect questions from different sources, and if you cannot do that, you are free to ask me. Okay. And yesterday in my previous class I have given homework, and I am very happy that some students have submitted the homework to me, and I am very happy with their approach. Likewise, I am telling my dear students, you people should submit the homework to me, no matter whether it is right or wrong. So with this I want to end up my speech here today or session here today. Thank you, my dear students.